Looks very mathematically in depth, but it's not really that bad. Looks like this. If I can actually find it here. Oh wait, sorry, I don't want distance. I want the distance between 2 points. Well, we do get to the midpoint, but let's do distance first. The distance between 2 points. Is this. The letter D equals, that stands for distance, the square root of, like this, I hope, x, make sure I get it right, x2 minus x1 squared plus y2, y sub 1, y sub 2 minus y sub 1 squared, I believe. So put this somewhere where you can find it and or see it. It's a good one. And I might even be able to show you where it comes from. Not that it's here. Got that? Curious minds want to know. So here we go. Take a look, see at this. What they're saying is this. Let's say you have a coordinate system and you have this point here that is 3, 2, and you have this 3, 2, and you have this point here that is -2, -2. If you want to find the distance from this point to this point, you would put it in that formula. Why, you ask? Where does that formula come from, you ask? Why? It comes from the Pythagorean theorem, really. Because anytime you have 2 points, Jeremy Schwartz, on a coordinate system, you can always make a right triangle that looks like this. You just come straight down and straight across. Correct? And this line is always going to be the hypotenuse. So you could always use, the Pythagorean theorem, which says a squared plus, it says a squared, I'll find a place where this writes, a squared plus b squared equals c squared. Okay? Which ones are a's, b's, and c's? It doesn't matter which one you call this. A, B, C. If I were solving for the letter C, which is what I'm looking for when I look for distance, letter C is this distance right here. How would I solve this equation for the letter C? Not knowing any of this other stuff, what is the letter C? How about this? If C squared equals 49, what does C equal? Y. So if C squared equals this, what does C equal? C is going to equal the square root of a squared plus b squared. Right? Well, how do I find out what a squared is? How do I find out what a is? What do? You subtract this point from this point. That's where on the distance formula. See, can you see this? Can you see this in here? The square root. This was actually c. The distance is the hypotenuse. To figure out what this was actually a and this was actually b. To figure out the distance of a, you just take the 2 and subtract them. To figure out the distance of b, you just take the 2 and subtract them. So this whole distance formula is just the Pythagorean theorem all rearranged. Good for you, Mr. Hahn. That didn't make any sense to anybody. So let's just plug it into the distance formula. Well, let's do it. How can I figure out what is this distance of A? Well, you know that it's 4, right? Is it not? 1, 2, 3, 4? Yes. Somebody's not in agreement here.
Yes. I'm not interrupting you.
I just made it.
Oh.
I just went straight across from one point, Nikki, and straight down from the other point. That always makes a right triangle. But you don't have to know that because you're going to use the distance formula.
But why
You are
not
not
use
going
that
to stick this into the Pythagorean theorem. I'm just trying to show you where the distance formula comes from.
one? But
See.
why wouldn't you do the Pythagorean theorem seems easy, why just more?
Well, we haven't really done it yet with the Pythagorean. Because you're not gonna always wanna draw a triangle, and you're not always gonna, sometimes they're just gonna give you the 2 points. So you're gonna spend your time to draw the whole coordinate system, you're gonna plot the points, and then you're gonna look for it. So not all, I guess if you really wanna always do it this way, Lauren, I guess feel free. Okay. Now, so let me show you, where does the number, we figured out this is 4, right? If you take the 2 y's and subtract them, what do you get? 2 minus a negative 2 is actually 2 plus 2. That's where the 4 comes from. And the same thing for the b's. I know my b is 1, 2, 3, 4, 5. That comes from when I take 3 and minus a negative 2. Okay, so that gets you your 5. So enough of that, I'm going to plug it into the distance formula says this. And it doesn't matter the order you put them in, but x2 minus x1 plus squared, y2 minus y1 squared. So once you know your points, okay, which you don't have to draw this whole thing out, this is just the points. You just need to pick one to be the sub 2s and one to be the sub 1s, and it doesn't matter which one, Jackson. Which one, Jackson, would you like to be the 2s, and which one would you like to be the 1s?
3, -2.
This one you want to be the 1s or the 2s?
Oh, 1.
Okay, so this is x sub 1, y sub 1. This is x sub 2, y sub 2. And you just plug the points in for your things here. X sub 2 was negative 2, negative 2 minus x sub 1 is 3, correct? And we're going to square that, plus, what's my y's? Y sub 2 was negative 2 minus 2 squared, and that's all going to be the square root of. And negative 2 and negative 3 is a negative 5 squared plus a negative 4 squared. So the distance is going to equal the square root of 25 plus 16. So the distance equals the square root of 41. 41. You can't simplify 41 anymore. So this distance from here to here is the square root of 41. If you were guessing the square root of 41, you would guess what? 6 between, so it's pretty, yeah, between 6 and 7. Which makes sense, right? Because this was 5 and this was 4, so. Alright, let's do one just with a point. So let's say we should have a race. I'll have Lauren do it her way, drawing the coordinate system, and I'll do it my way. Let's just say you have a point at 4, 2, and another point at negative 6, 8. And I cannot stress enough you just taking your time and putting the stuff nicely into the formula. The distance equals the square root of x sub 2 minus x sub 1. Somebody's not getting a ruler for this, are they? y2 minus y1. Because you're not drawing any of this out, let's just put the points in. I again would suggest putting whichever way you want to do it, you know, make this the 1s, it doesn't really matter as long as you're consistent. Make that the 2s, and you just plug it in. Distance equals the square root of x sub 2 negative 6 minus 4 squared plus the y sub 2, which is 8 minus 2 squared. So distance is going to equal the square root of negative 10 squared plus 6 squared. Distance is going to equal the square root of 100 plus 36. Distance is going to equal the square root of 136. Can I simplify the square root of 136?
Yeah.
What goes into it? 2. How about 4? Square root of 4 times the square root of 30. Oh no, 4 doesn't, yeah. 39? Oh, 4 doesn't go into 26.
Times the square root.
What?
Like
4 times the square root of 34. Yeah.
Yeah.
Square root of 4 times the square root of 34. And the square root of 4 is 2. So the answer is 2 times the square root of 34.
Actually, it can be 4 times square root of 34, actually.
I know, but the square root of 4 is 2. That's why I go with that. Wait, 2. Right? Jack, am I still right or am I wrong?
You're right.
17 times 2, but that doesn't change anything. John?
So whoever needs y2 minus y whatever again over x.
That's to find slope. This is distance. And then we have the last one here.
Wouldn't
Now-
the answer actually be 34 then? Because oh wait, no.
2 times 34 is not 34 times 34. It's 2 34s added, square root of 34s added together. And that's why math is kind of complicated. Now the midpoint formula. That was the distance one. The midpoint formula is this. Midpoint equals x1, x sub 1 plus x sub 2 over 2. This only makes sense if you think about it, but we're not real big into thinking. Comma, y1 plus y sub 2 over 2.
Is that
This is a comma, because you're looking for 2 points. You're looking for the x value and you're looking for the y value. And again, what this means is this. If you've got a coordinate system, and let's say you have a point here at 1, 2, 3, 4, 5, 6. 1, 2, 3. This is 6, 3. And you have a point at, let's say, 2, negative 3. The midpoint formula will tell you where on this line the exact middle point is. Okay? Which is nothing more than taking the average of the x values and the average of the y values. Jackson?
When you have to graph it out, they
No, you can just use the points, unless you're going Defferberg and you want to graph it out. So really, all you're going to do is this. Again, you need to pick which ones you want to be the sub 2s and the sub 1s. If I make this the sub 1s, and this one the 2s, okay, you just take, I'm actually going to do it because I don't want to cut any corners here. x1 is 6, plus x2, which is 2, cut that in half.
Which is 8.
8 cut in half is 4, that's my x point. And then I do the same thing for y, which is 3 plus a negative 3,
Which is 0.
and 0 over 2 is 0. This 4 comma 0, 1, 2, 3, 4 comma 0, should have been my midpoint. I just drew my line a little goofy. I just missed my line. Problems and or questions and or concerns? One more. Jackson?
Is there a way to figure it out without me getting these? Like,
Well, if you don't have points, you don't have a line.
could you?
Let's say the midpoint of 8, 3 and negative 2, 1. So the midpoint is going to be your x1 plus x2 over 2, y1 plus y2 over 2. So it's just your x's add together, 8 minus 2 over 2, which is 3. 8 minus 2 is 6, 6 cut in half. And the y's would be 3 plus 1 over 2, which is 4 over 2. 3 comma 2 is your midpoint of these lines. Would that work? Does that sound right? 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, and -2, 1. Would 3, comma 2 be 1, 2, 3, 1, 2? Sure.
Scale is not perfect.
How's that for fun and exciting? No, Nick, don't.